Okay, so we're going to try and convert the polar equation to rectangular form on our homework in our problem set, numbers 36 through 39. And I'll try and look at 58, 59, and 60, which are also in polar form, and we're going to convert them to rectangular form. So these problems are due next class, but we didn't go over this in class, so I just wanted to make sure that y'all knew how to do it. So if we look at number 36, 6r cos theta equals 12. And what I'll recommend you guys to do is maybe look at the first two, and then once you get comfortable with it, try and do the next two on your own. That way you can at least try it and then check your answer with the video. But if we look at this, 6r cos theta equals 12, your ultimate goal in all of these problems is to write something as r cos theta or r sine theta, because we know that r sine theta equals y and r cos theta equals x. So if we can get our polar equations into any of these forms, that's going to be helpful for us. So this one's pretty easy because right off the bat we see that we have an r cos theta in here. So what we can do is we can substitute that for x, because we know that that's just x, right? So if we write 6x equals 12, this one's a pretty easy one. We know that x equals 2. So that's literally it for the first one, for number 36. If we look at number 37, here, let me write 36 here so y'all know. All right, that's 36. If we do 37 now, we have r equals 3 cosec theta, right? Now what can I do? So let me think about this for a second. Well, how can I rewrite cosec theta? Cosec theta is the reciprocal of sine of theta, so I can write cosec theta as 1 over sine theta. And if I put the 3 on top, it'll look like this. So r equals 3 over sine of theta. Now I can multiply both sides by sine of theta, and I'll get r sine theta equals 3. And r sine theta is just y, so I get y equals 3. So the motivation for doing this, for rewriting cosec theta, was when we have a reciprocal function, it's easier to write it in its original it's easier to write it in terms of sine and cosine, because if we can write in terms of sine and cosine, there's an easier way to write it as r cos theta or r sine theta. So that's what I would do. So that's 36 and 37, and I'd encourage you to pause and try and do 30 and 39 on your own. At this point, those are a little tricky, so try them first, and then if you get stuck, I'll solve them right now. So pause the video if you want to. Okay, all right, I think that's good enough. All right, let's look at 38 real quick. So if I'm doing 38, I have r equals 6 sine theta. Now, here's the question. How do I get this to rectangular form, right? So let me think about this, because this one's a little trickier. It's not as, it might not seem as obvious, but let me try something. So our goal is to get an r sine theta, right? So what I can do maybe is I can multiply both sides by r. So I'll get r squared is equal to 6r sine theta. And we know that r sine theta is just y. So I can write that as 6y. R squared, well, we know that, well, if I have a right angle triangle, this is my origin, right? This is my x, this is my y, and so that's in terms of rectangular. In terms of polar, this would be theta and this would be r. We know that r, by the Pythagorean theorem, is the square root of x squared plus y squared, which would mean that r squared is equal to x squared plus y squared. And something you should notice is that this is actually the format of this, or this is the format of the equation of a circle, right? If you have a circle centered at the origin, that should be radius, so that's the radius, so radius squared is equal to x squared plus y squared. And that's essentially what that's where this polar equation, or this polar, these polar coordinates come from, and that's essentially also where our sine and cosine come from, because you can look at a circle, you can look at the unit circle where your radius is just 1, and you'll have x squared plus y squared equals 1. And I actually, that's a good opportunity to experiment with and see how we can connect this idea that x squared plus y squared equals 1 to sine and cosine, and you'll see that it's pretty obvious what it is. But if we continue with this, we know that r squared is equal to x squared plus y squared using the Pythagorean theorem and then squaring both sides, as we saw. So I'll write that, and I'll write that as x squared plus y squared. Now what I'll do, just to clean things up a bit, let's do this. We'll write this as x squared plus y squared. That's an equal sign, right? Yeah, that's an equal sign. Minus 6y is equal to 0. Let's see. When we write an equation of a circle, usually we say x minus a, that quantity squared, plus the quantity y minus b squared is equal to some radius squared, right? Where a comma b is the center of the circle. So this is just a translation right and a translation up, assuming that a and b are positive. So x squared is the only squared term, so we don't need to worry about x minus a squared. A is just 0 in this case. If we look at y minus b squared, we can figure out a way to write this as a perfect square. Let's see. So if we wanted a perfect square, we have, well, that would be 2 times 3. That means I would need to add a plus 9 here. But because I don't want to change the value, I need to add 9 and then subtract 9 and let that equal 0. And the reason so a lot of you might wonder, where did I get this 9 from? Well, I know that the formula, or not a formula, but the identity, or if you simplify this, a perfect square, or some a plus b or a minus b, that whole quantity squared, I'll get y, in terms of y and b, it'll be y squared minus 2yb plus b squared. So I know that I have a y squared here. I know that it's a 2yb. Well, that means I have a y here already. So that means 2b equals 6. And if I have 2b equals 6, that means b has to equal 3. And if I know that b equals 3, 3 squared is 9. That's where I got the 9 from. And I just subtracted 9 to keep the value the same. Because if I have to add 9, then I have to subtract 9 to not change the value. So now I can look at this whole thing as y minus 3 whole squared. And I'll have x squared plus y minus 3 whole squared. And I can just move 9 over to I can add 9 to both sides. I can just move that over. And I'll have x squared plus the quantity at y minus 3 squared is equal to 9. So that's the answer for number 38. That's where I got that from. I don't know. Maybe you could just stop here. This is just a cleaner way to write it, I guess. Yeah. This really shows you where the circle is, because now I know, just by looking at this, that my radius is 3 because the square root of 9 is 3, and my center is at 0, comma, positive 3. So this is my center, and my radius, so my circle is going to look something like, oh, nope, it's supposed to cross through the y-axis. Yeah, I can't draw, but there you go. That's the idea. Okay? So once again, you're just trying to get something in terms of r sine theta. Once you get there, it should be pretty easy. All right, give me a sec. Let me erase my board. So if we're looking at number 39, on number 39, we have r equals 2 plus 3 cos theta. So once again, this is a little bit trickier because we do have an extra constant that's being added here. But same thing, we need to get an r here. So to get an r cos theta, we're gonna just same thing. We're gonna multiply both sides by r. I'll get r squared equals 2r plus 3r cos theta. R squared is gonna be x squared plus y squared. And then we know that r, or 2r, right? We know that r is the square root of x squared plus y squared. And I know that r cos theta is x, so that'll be 3x. Now, let me think about this. Well, what I can do, maybe what I'll try doing, is I'll subtract 3x from both sides, and I'll tell you why in just a sec. So it'll be x squared minus 3x plus y squared equals 2 times the square root of x squared plus y squared. So the reason I did this was because if I move this to this side, now if I square both sides, I don't need to worry about expanding the binomial squared, right? It'll be this term plus this term, the whole thing squared, and that'll be ugly. So instead, if I move this over to this side, I just have to square this, and I'll have to square this, right? I'm not going to go ahead and expand this because I don't think there's a point in expanding that. I'm just going to write that as x squared minus 3x plus y squared, that whole quantity squared, equals 4 times x squared plus y squared, because 2 squared is 4, and that square root, if you square it, it just gets rid of the square root. And I'd actually stop there. I don't think there's a need to go further than that. But yeah, that'll be the answer for, this is for number 39. So that's how you do the ones that were given on the homework. Now, I actually graphed this, and once I graphed it, I got x plus, it looked like it was actually a circle, and it looked like it was centered at negative 1/2, comma 0, and it had a radius of 0.5. So it looked something like this. And because when I plugged this in, and because it looked really similar to that, I said, well, if it was a circle, then it would be x plus half squared plus y squared equals 0.25, right? And I also plugged that into the calculator, and it ended up being the exact same circle. Now, I'm not sure how you would get this from this. I haven't tried, or I haven't fully looked how that would happen. But I'm sure there's a good way to derive that. Maybe by expanding this out. I don't know. Well, I'll have to look at it. But I think that this should be sufficient in terms of converting from polar to rectangular. But it is a circle if you wanted to find out. And then I'll do the other ones too, just as extra practice if you wanted to take a look at it. Let's see. So that was number 39. Okay, so now, yeah, it skips numbers, but now we're on number 58, and we are at r equals 8 cos theta. This one is one of the easier ones, right? Because we can multiply both sides by r to get that r cos theta over here. And I know that r cos theta is just x, so r squared, well, why write r squared? We know what r squared is. We know that r squared equals x squared plus y squared. And r cos theta is just x, so we know that that's 8x. Same idea that we did last time. We're going to try and complete the square. Yes, that's what we were doing. Sorry, I forgot what it was called. We're essentially what we're doing is completing the square. So minus 8x, and we have a plus y squared equals 0. We need to add something here. So let's see. So 8 is 2 times 4, so that means I need to square 4 to get 16. And if I add 16 to one side, what I did last time was I said 16 minus 16 to not change the value. This time, here, just to show you that there's another way of doing it, if I add 16 to this side, I can also add 16 to this side. That'll be the same thing. Yeah. So this trinomial, these first three terms, that is x minus 4, the quantity whole squared, plus y squared equals 16. And once again, that's a circle centered at 4, comma 0, and has a radius of 4. Yep. All right. Cool. So that was number 58. Now let's look at number 59 real quick. R equals 2 plus 3 sine theta. Very similar to number 39 that we were doing earlier. Same idea. R squared equals 2r plus 3r sine theta. R squared is x squared plus y squared. 2r, well, that would be 2 square roots of x squared plus y squared. And plus 3y, because r sine theta is y. Same thing, we're going to subtract 3y from both sides. x squared plus y squared minus 3y is equal to 2 square roots of x squared plus y squared. If we square both sides, we'll get x squared plus y squared minus 3y. That whole quantity squared is equal to 4 times the quantity x squared plus y squared. So that's what I would, and let's see. Yeah, I'd honestly just leave it like that. And judging from our last one, the last one was a circle, so I'm guessing this one will be a circle. I don't know. I haven't graphed it. That's, yeah. Yeah, you can try that on your own and see if that works. And then finally, let's look at the last one, number 60. R is equal to 1 over 1 plus cos theta. Well, immediately what I want to do to get rid of this fraction is multiply both sides by 1 plus cos theta. If I do that, I'll get, and I'm just writing it out completely so that you guys can follow along, but that'll be r plus r cos theta equals 1. And look, what that allowed us to do was now we have something directly in terms of r cos theta, and that is just x. So we have r plus x equals 1. I can write that as r equals 1 minus x. I know that r is the square root of x squared plus y squared. That equals 1 minus x. So if I square both sides, I'll get x squared plus y squared is equal to 1 minus 2x plus x squared. I can subtract x squared from both sides. I'll get y squared is equal to 1 minus 2x. And if you, sorry, yeah, this is really messy, but I ran out of space. But I have y squared is equal to 1 minus 2x. I think that would be sufficient. I'd also argue that y squared plus 2x minus 1 equals 0. That's sufficient. Or not equals 2. I should yeah, write that neatly. And the other option obviously is to say that y equals the square root, or it technically should be plus minus square root of 1 minus 2x if you just take the square root of both sides. So I think that all three answers are acceptable. I'd probably just stop here. I think that's sufficient. But that's how you do number 60. And that's this is my, I'm sure there's other ways of approaching this, but this is my way of, I think that this is the most intuitive way of approaching it. If you try and get things in terms of r cos theta or r sin theta. Actually, I was reading it online, one of those websites where it teaches you like simple math stuff, and what they were recommending was that you directly plug in, well, we know that r equals the square root of x squared plus y squared, and you know that theta equals, I think it's tan inverse of y over x, right? Let me check. Let me just verify that for real quick. So if I have a right angle triangle, that's xy, that's theta. Well, opposite over adjacent, y over x. Yep. So that would be tan inverse of y over x. Or arctan of y over x, whichever one you want to call it. What they were saying was that you should directly plug these in. I'm not sure if that's the best idea, because if we just look at number 36, which we solved really easily because we recognized what r cos theta was, if we try and do that, this will be 6 square roots of x squared plus y squared times cosine of tan inverse of y over x. And I just think, did I put one too many parentheses? No, it's all good. Equals 12. And just looking at that, that's so much more complicated. And why do all the extra work when you can just recognize that that's x? So that's the other alternative. I'm sure there's a way to solve this, but yeah, that's not for me. All right. You guys can always contact me if you guys have any more questions. But yeah.